Welcome back. The beauty of what we just learned in tree traversal, which was O of n, we're visiting every node, is that it's the same as in graph traversal, because trees are just simply a type of graph. So using the same technique, instead of using left and right properties, perhaps there's 10 children, well, we can do the same thing using depth first search and breadth first search. And this is really powerful, right? Because graphs are used to model real life models, such as a recommendation engine in Amazon. We can now see what type of items are perhaps related or are the closest relation to the last book that we bought. And in that case, they would use something like breadth first search. Or on Facebook to see what type of friend requests I should be recommended. If I have a connection on LinkedIn, perhaps, I might use depth first search to see what degree of connection I have with that really important CEO. We use depth first search. And these are the basis of how peer-to-peer networks work, how Google Maps works, right? Which is really, really powerful. And I have a nice visual here. I have our visual algo here, our good friend, and they have a depth first search. And I made this little graph. And we can traverse now using, actually, let's do breadth first search first. And we'll start off with 0. So I'm going to enter 0 in here and see how depth first search would work. We check all the closest nodes, 1, 3, 4, 5, 6, and then we start with 1. Does it have any children? Yeah, 2, 7, and 8. And then we go next in line. 3, what about 4? What about 5? What about 6? They don't have any children? Okay, let's go keep going down to the next place that has children. And we traverse the graph, as you can see, starting with our closest neighbors and then going further and further out. With a depth first search, let's say we're starting at 0, and I hit go. We go to 1, then 2, then 7, and then we're going to keep going deeper. 8, we're going to go to 9, then 10. There's no more nodes, so we're going to go all the way back and go to the next in the list. That is 3, then 4, then 5, then 6. So just by looking at this, you might see what I meant when I gave you the information at the beginning of this section. That is, breadth first search is usually good for shortest path. That is, what's the closest to our node? What are the most related items on Amazon? Who are our closest friends on Facebook or closest connections on LinkedIn? Versus depth first search, which is really good to see if something exists. With depth first search, we're able to go really deep into a graph fairly fast than breadth first search that might cost a bit of extra memory. Let's talk about these two algorithms in more detail when it comes to graphs.